just so you know, this is not a marketing pitch. Hopefully, we'll have a discussion that brings some good thoughts to mind as you guys think through what AI looks like in some of your applications. One of the things that often happens in AI terrestrially is we skip right to the end. We start talking about the products. We start talking about the benefits we can get from AI. On the ground, right, you essentially have unlimited resources in a data center. You have kind of an abstraction layer between you and the hardware. The generations of hardware can kind of move underneath you transparently, and you don't think a lot about it. That matters a lot in space and in general on edge embedded solutions. You really need to care about the hardware platform. You need to start thinking about that. And so we're going to talk a little bit about how we can go about that together today. Where it matters that AI is evolving at a much quicker rate than the hardware, and yet the hardware is also moving at a rate quicker than traditional Moore's law. Just for a little bit of context, when we think about AI, particularly in space, we think about a couple application areas that really come to the forefront. We're either reducing data, and we're doing that so that we can get the appropriate data down to the ground. So that's some of the areas on the top column. The other thing we're doing is, maybe more importantly, is we're getting the right data to the end user and reducing latency. So that really matters a lot. That's getting the right data in operational time frames distributed. And then the third area in the bottom row is really when we start thinking about autonomy. And that autonomy can either be across the constellation, or it can be when we start thinking about individual actors that are separated either due to distance, bandwidth limitations. Autonomous decisions need to be made without ground in the loop. So just as a real simple example, if we're looking for ships in our scene, right? In a traditional loop, we might download a lot of data, some of which would be non-usable, and then we have to discriminate within that scene with the use of a human in the loop to find that target. Instead, what we start thinking about is how can we speed that up? How can we, instead of waiting for the next operator on a shift to be looking through that data set, we actually are tipping off and identifying that desired object in the scene using AI. You think about one of the other concerns that happens is when you have a man in the loop, it's just how does that really scale? And particularly when you start building out a constellation with a lot of manual steps in the loop, the scale breaks down pretty quickly. So that's an area where we really want to consider using AI. What I'm suggesting today is we start thinking about wherever you are in your journey with AI, is you start thinking about the hardware platform now. You start thinking about how you're going to deploy the AI and what target environment you're going to realize it on, even before you've decided exactly how you're going to use AI. Before you've decided on the models, before you've decided whether you're going to use an existing model and train it, or you're going to develop your own network, you need to start thinking. And the reason is the cycles to get hardware on orbit, that takes a long time to do that design, to that integration, to get an asset launched, to get it operational. So what we're challenging people to do is think about a hardware platform that you can't really future-proof with AI, but you at least lean forward a little bit. You start getting assets on orbit that you can later deploy models to. Start thinking about what could last for 5 years. Start thinking about, am I deploying in an operational environment that is open and can evolve as the technology underneath it with AI continues to evolve? Start thinking about, is there enough flexibility in the hardware that I'm deploying in order to evolve my system over time? As my sensors maybe evolve, to start processing more data from either different sensors or sensors with more throughput. Obviously, when we start talking about embedded, it really matters what platform you're talking about. If you're in a CubeSat, that doesn't mean you're not doing AI. There's a lot you can do with AI in a CubeSat, but you have certain physical constraints to keep in mind. On the other end, obviously, if you're on the space station, maybe that can look a little bit more like the ground, and you can be less constrained by the platform that you're on. What we're seeing right now in new space is the kind of collection of small sats and microsats, mini sats offer a really nice compromise where you can get a quite significant amount of processing on orbit along with your primary sensor. With a CubeSat, you're forced to make some really tough calls between how much power and swap you're providing to the payload versus your processing solution. The other thing I would encourage you guys to think about is with your platform constraints, you are not limited to what type of processing you can use. You can use the CPU. There's things you can do on the FPGA, and then there are things you can do with dedicated systems that, whether GPU, NPU, that are a little bit more tailored to vector math. I want to give you a couple examples of some of what we've seen recently. One of our partners is deploying AI to an FPGA fabric. So this is an example where you don't need an NPU, GPU in order to realize your solution on orbit. Another we're seeing on a very small platform is the Starlink constellation. The Starlink constellation is a NASA formation flying constellation where there's autonomous navigation and collaborative decision making in terms of the constellation formation that's happening, and that's running on a very small CPU. And then you have maybe what's a little bit more what you consider a traditional platform, where you have some dedicated compute to do some of the neural network implementation on dedicated AI ML engines. So one of the things I wanted to do is let's just think through a little bit of a scenario together. Let's think about a small sat that's going to be in LEO orbit for 5 years. On the small sat platform, as I mentioned, there should be some pretty significant compute that you can bring to a problem set, right? So of all those three options that I mentioned, we should be able to bring in a GPU, NPU, AI engine to bear. And let's think about, in this case, that we're developing a custom model, a network from scratch for a particular application. So in this case, let's look through a trade space. This is not saying that any one of these solutions is better, but for a particular application, you might make certain trades here. So let's look at the Orin embedded in one case, the Ryzen, and a Versal. I happen to pick a Versal chip in this case for one of our products, but this could also be a 1902 from somebody else's platform as well. Really, the idea is we're just thinking through this problem set together. So in this case, we're looking at some of the discriminators. So let's look at some of the places that are red or green. So a couple of these implementations don't have FPGA. So that's totally fine. But if you need a custom implementation of an interface, now you're going to bring that hardware as a separate piece of your architecture. It's not embedded in the primary chip. So there might be some swap implications, but again, you're on a small sat. So that's not going to necessarily remove them from the trade. The other is just the I/O that you get from an FPGA implementation. Next row, the AI performance. We can use multiple metrics. Benchmarks aren't ideal, but they can kind of give you an idea of the gross order of magnitude that we're looking at. So in this case, we're looking at TOPS. And you can see some significant advantages to using the NVIDIA GPU or using the Versal AI ML cores in that case. Of course, we're going to space, so radiation matters. One of the things with the Orin side, it comes as a SOM, right? So you're not able to buy just the chip. And so the SOM is not necessarily controlled. You haven't controlled the BOM for that. You haven't been able to necessarily scrub that hardware. So it's something to consider when you consider the lifetime of the mission and the radiation robustness of the solution. Versus the Ryzen and the Versal, you can buy the chip itself and understand its radiation performance, and then you can put an ecosystem of parts around it to appropriately match your mission risk tolerance, your mission lifetime, and your radiation performance. And then finally, we think a little bit about the tool chain and ease of use. Obviously, there's kind of this almost synonymous relationship with NVIDIA and AI at this point. There's a really robust tool chain. There's a lot of resources online. You can kickstart your development quickly, so there's certainly an advantage there. But that's not necessarily when you're talking about an embedded solution and with design a 5-year LEO mission. That's again, there's probably room on your team to bring that expertise in house to develop a more challenging environment on the parcel. But it certainly is a little bit more of a challenging environment to develop on. So this is just one example. I'd be happy to talk through different mission sets and different constraints on swap, different cost profiles, different scales, economies of scale as you build out your own network. And the trade, you could redo this trade for your environment. So I'm happy to have those discussions offline with you, but hopefully this was helpful to just start thinking about really my call to action slide here is just start thinking about this early. As I mentioned earlier, let's start planning before you need AI, just because it takes a long time to get that hardware in orbit. Put some extra compute into your mission design early. Start thinking about the open systems that you would end up implementing, and pick partners, pick hardware that can evolve with you as you start really turning AI into mission value, right? This is all academic unless you're realizing value for your mission to your customers through the use of AI.